Okay, page 13 of the IO notes. We're pretty much, we're on the last topic now, and so I just mentioned reentrant functions. So basically with a reentrant function, you can have multiple copies overlap each other in execution. So reentrant function instances can overlap in execution. And how this could happen, one example would be that you're running ISR0 and it calls a function, and partway through executing that function, a higher priority interrupt request preempts it, and then the ISR for that runs the same function. And if that function is using any kind of global state or static state, so that's global variables, static variables, then they can interfere with each other. You can get errors happening. So they cannot use static state. So that means global or static variables. So here's an example. uint32 type is the return value for this function, return type for the function I should say, and the function is called countup. Doesn't take a parameter, and this is a trivial example. It's got one function that's been declared static. It's uint32 type, and it's the count. So what it does is it increments the count, and then it returns the current count value. This is an example of a function that's not reentrant. So static is like global, so it lives for the duration of the program, but with local scope. So you can only address it, or you can only talk to it from within the function, but it has the duration that a global variable does. So right from program start to program end. So the same copy is shared by all invocations of this function, and global or static variables are initialized to 0. So local variables do not have default initialization in C, but statics and globals do. So that's our example function. And just to illustrate what could happen is, let's just say that we have the application code and it's running line by line, and then it gets preempted, and so now ISR 0 is executing. So it's executing some instructions. It invokes countup, and what's going to happen in countup, if you look at that, it's going to load the value from memory. Really what I'm focusing on is this line right here. So it's going to load count, it's going to increment count, and then it's going to store count. So load into a register, increment it in the register, and then store it back to its location in memory. So that's what the count++ does. So that is this. But let's just say that this gets preempted right here, and so we go over here and we run ISR1, and ISR1 is going to do some statements, and then it's going to invoke countup. And let me just draw a box over here. So here is our static variable count, initialized by default to 0. So in ISR 0, it's going to load a 0 into a register. It'll increment it to 1, and then it's preempted. So now ISR 1 is running, and it's going to load count, and the count has not changed in memory, and then it will increment the count, and then it will store the count. So it loads a 0, it stores a 1, or sorry, it increments it, and then it stores it up here, so count now becomes 1. And then let's just say that our ISR 1 finishes executing, so it goes back to here. So we go through there, go back to here, and so now we're going to store count. ISR 0 is going to store count from a register back to the memory location, and it's overwriting the same value. So we missed one of the changes to count because we overlapped the execution, and they're using shared state. So that's the problem. Next we'll talk about the solution.